So next for us is the Google Cloud Platform fundamentals. Now, as I said before, please ask questions at any time throughout the event. We have the Google experts on the standby to answer them. Do not hesitate. The more you ask, the more you get. We will compare these terminologies that you're familiar with an on-prem or if an AWS to a corresponding terminologies on GCP. We'll explain you how the resource hierarchy works in the Google Cloud Platform and discover ways to control the permissions with, you can say, the cloud identity and access management. So we're going to learn about the first thing, Google Cloud Platform terminology. We will compare the terminology that you're used to from your source environment to the Google Cloud Platform equivalent. The first thing we will talk about is compute, on-prem versus GCP. Compute, storage, and these are the three things that you would always need when you are active running an application. One is compute, like your vCP, your RAM. Then you would need storage. Where are you going to store your app data or anything that requires storage? And finally, identity, who can do what. So when you're running the virtual machine on the premises, you know that you're responsible for hypervisors which are running them. For example, the VMware running ESXi's or the Hyper-Vs and the KVM. You're responsible for maintaining those infrastructure all by yourself, all the networking, the storage, and the hardware life cycles. Now, when you come to Google Cloud, virtual machines are actually called as compute engine instances. Compute engine instances, and they run on a Google Compute Engine service. So when you're running a compute resource in a simple language, a VM on the Google Cloud, that is called as a compute engine instance run by a Google Compute Engine service. So with Compute Engine, you do not have to manage those infrastructure anymore, and even the hypervisor, because Google is going to maintain these services so that you can really focus on the actual virtual machine instead of what underlying system that runs. Is it running on Intel hardware? It doesn't matter to you. You are just focused on the compute that you want. And once you compute, you would need storage, because if you remember the storage for on-prem, you have used something like the directly attached storage, which is called as DAS, the network attached storage, which is called as NAS, or the SAN, the most popular, which is a storage area network to provide the storage services to your machines on on-prem environment. So what Google Cloud does, it provides you with a VM storage as a service. So you are not required to manage again any of these common yourself, and we'll talk about storage in the next module. Now, one important thing that you also have is identity. Now, typically when you have an on-prem resource, you have some kind of an Active Directory on LDAP servers, which are going to maintain the identity access for you, and then needs to be remain highly available at all point of time, because if they or something goes wrong with them, then you will lose access to your environment. But GCP, it provides you a fully managed cloud-based identity as a service offering called as cloud identity, which you can either extend to your even on-prem cloud directory services to the cloud with the help of sync, or create a new user directory for environment. So when you are using the Google Cloud Identity and Access Management, which we also call as IAM, you can control and grant any kind of granular access to the resources in your cloud environment. Let's understand the Google Cloud Platform resource hierarchy and why it is even required. Google Cloud resources, if you mention about resource, anything that we are going to run on the Google Cloud environment, they're organized in a hierarchically managed manner where you have an organization node, which is basically the root node in the hierarchy. Then the projects that you see here, all the folders, they are basically the children of the organizations and the other resources. Now you can set an IAM policy, which is identity and access management policy, at different level of the resources. The resources are kind of inheriting the policies of the parent resource, and then you can kind of build your system around that. When you're talking about the resources, as I said, it is easy to understand the GCP resource hierarchy from the bottom up. Now, all of the resources you use, think about like a virtual machines or the cloud storage buckets or maybe tables in the BigQuery or even anything else on GCP, they are organized into a logical constructs that is called as a project if you go from the bottom up. Now, the projects can contain the bulk information for the resources in the project, and they will also maintain any kind of necessary IAM permissions, which is going to dictate who can do what with the resources within a project. You don't want to have anyone to have anything to do with it. You've got to allocate the specific permission or identity and access permissions. And then these projects optionally can be organized into folders, where folders are being able to contain other folders also, and all the folders and project, if you see, they're finally under an organization node, which is also called as an org node. All the Google Cloud Platform resources, they belong to a Google Cloud Platform project. The projects are everything. They are the basis for enabling and using any GCP service. Think about like if you want to leverage an API, you want to enable billing, you can add or remove collaborators and assign and the permissions if you've done that. Now each project is basically a separate logical container or compartment which has all those individual cloud resources. And then I can, inside these projects, put all the resources that may need be required to run it. So you have these logical project now separation of your dev environment, of your production environment, and for your testing environment. And each project, or each resource, whether it's your VM or storage bucket, it's going to belong to exactly one project only. Now different projects can have different owners and users. For example, the dev project may have the owner as the dev lead, the testing may have the testing lead, the production may have the lead as the CTO or anyone. So every project can have different owners and users, and then they're all going to be built separately and they will be managed separately. So your project is one of the most important thing that everything happens inside the GCP ecosystem. What's an organization? Now, if you remember, we said we have an organization, and then with the organization, we have the project inside the organization. Now, you probably want to organize all of your projects into one single structure. So you have the company, and then you have, let's say, dev and production and testing, for example. And most companies, they really want to have a centralized visibility on how the resources are going to be used and how you're going to apply policies centrally. And this is exactly what the organization node is designed for. It is for the top of the Google Cloud Platform hierarchy. If you go bottom up, we have projects, folders, the org. Now, there are different roles, or I would say special roles, which are associated with the organization node. For example, you can designate organization policy administrator so that only the people with the privilege can change policies. You can assign a project creator role, so which is basically a great way who can spend money and delegate permission. So let's say if I assign someone as a project creator role, so this person can actually create a project under the organization, and then under that project, the resources can be created. So this is basically a permission where who can really spend money and who cannot. If you're a G Suite customer or you have a G Suite domain, then GCP projects will automatically belong to your organization node, which is typically, you can say, a domain name that you will use for G Suite. If you do not use G Suite, then you can leverage the Google Cloud Identity and then create an organization, and we'll talk about identity a bit later. If you look at this example of how this resource hierarchy works, like this is where you might organize your resources. So, for example, you see we have three projects. Okay, bookshelf, 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 same name, and each of these uses resources from different GCP service. If you observe in the diagram, we have not used any folders in the current organization structure. So if you use the folders, obviously it would be helpful for you, and you can always implement them and apply policies needed. Now, if you see resources which are running, they're inheriting the policies of their parent resources. For example, let's say if I set a policy at the organization level, and then this policy is going to be inherited by all its project, and then this inheritance is kind of transitive. That means that all the resources in this project will inherit the policy too. And there's one important rule that you should always remember is that the policies which are implemented at the higher level in this hierarchy, they can't take away access that's granted to a lower level. For example, you may think, okay, if I've applied some policy on the example.com, then something that's applied at the resource is going to be gone. No. Suppose, let's say, a policy is applied on the bookshelf project, which gives a user the right to modify maybe a cloud storage bucket. But then there's a policy at the organization level that says Vishal can only view cloud storage bucket, not change them. So the more generous policy will take effect. Keep this in mind if you're designing your policies, okay? That the policies at the lower level and the policies which are at the higher level in this hierarchy, the hierarchy will not take away the access that's granted at the lower level. So the next thing is IAM. One of the favorite things, believe me, and it's one of the most important thing. As now I will introduce you to the cloud identity and access management and how do you use it to control and secure your environment. So what is identity and access management? It's basically a way of identifying who can do what on which report is what IAM does for you. So what is the who? The who can be a person, can be a group, can be an application, a specific privilege or action. If you can see a who can be a person, as it can be a Google account. It can be a service account. Service account, something which is give us some permission which is given to a specific Google service. It can be a Google group. They can put a set of users in a group and assign the same permissions or some kind of cloud entity. The can do what part of IAM policy is defined by a role. Now, there are three kind of roles in the cloud IAM. Let's try and understand each of them. The first one is primitive. The primitive rules are broad. That means you can apply them to a GCP project. They can affect the resource of the entire project, from the virtual machines to firewall rules, databases and logs. So when you talk about primitive roles, you can call them more of like the owners, the editor, or maybe the viewer roles. And let's say if you are a viewer on a given resource, then what you can do then, you can only examine it, but cannot change its state. If you're an auditor, or sorry, editor, you can do everything a viewer can do plus change its state. And if you are an owner, you can literally do everything on an editor plus manage roles and permissions on the resource. And the owner role on a project, it's basically the root. It's like it lets you do one more thing to, you can set up the billing. So you can really do everything out of the owner role. And mostly companies, they want someone to be able to control obviously the building of a project, right, without the right to kind of change the resources in the project. So you can grant someone the building administrator rerule that, but be very very careful. If you have several people working together on a project, let's say which is concerning some kind of sensitive data, then primitive roles are probably too coarse, and that's where you can in GCP we have an option to provide finer grain type of roles. So it's very important. So you have predefined roles which also are something that you can Google offers you, and if you have something very customized, you can also do the customized role. So it's very important that can do what is their what. So obviously, when you have a permission, you want to give it to a user or a group, right? A service account on the role of a specific element of the resource hierarchy. When you give a user or group a role on an element on the hierarchy, then what happens that the policy will apply to that element you choose and the value with that. So you choose, when you put a policy, it's going to go back to all the resources that we have in that case. So we have now, can understand that IAM is about who can do what on which resource, and now we have a slight understanding on that part. Many new GCP customers, they basically get started by logging into a GCP console with a normal Google's Gmail account. And this approach, I would say, is a very easy one to get started with, but it's the disadvantage would be that your team identities are not centrally managed. So for example, let's say someone is going to leave your organization, there's no centralized way to remove their access to your cloud resource immediately. I mean, GCP customers who are also a G Suite customer, as I said before, they can define GCP permissions in terms of also G Suite users in group. And this way, that's if someone leaves your organization, then administrator can immediately disable their account and remove them from any associated group using the admin console. As I said before, there are customers who cannot be a part of the G Suite or who are not using G Suite. They can get the same capabilities. So something called as cloud identity. Now, cloud identity, what it does, it allows you to manage the users and the groups using the Google Admin Console. So you can access Google Cloud by a Gmail account or with the help of a Cloud Entry or G Suite account or a service account. A service account is a special kind of account which belongs to either an application or a virtual machine instance. It never belongs to a person. Let's say you have a VM and that VM has some requirement to launch more VMs. Then you will assign a service account role of launching a VM or a compute admin to the virtual machine instance for that purpose. So applications use services accounts to make all those authorized API calls. You can call and create as many service accounts as needed to present the different logical components and security boundaries, and then group all of these accounts into a named collection that's called as a Google group, and put them in all the account and the service account in that. And then every group is going to have a unique email address that's going to be associated with the group. And I would say Google Groups are one of the most convenient way to apply roles and permissions, because then you're not going to individually apply them. One of the best example I'll give you. Let's say you're a CTO, okay, or you have a person who is responsible for managing the Google Cloud, and he had all those necessary permissions and roles. And one day he left the company, and you kind of deleted his email address. The moment you delete his email address, all the roles which were assigned to him are not inaccessible because you don't have the person anymore. So the best way would have been that you create a group, add all those necessary people with the relevant permissions, and add the policies and permissions on the group. So even someone leaves them, you just remove the person and add someone else new who's going to be part of that. The one thing that you should also remember, that you cannot use the cloud IAM to create or manage the groups. You can use the cloud identity or G Suite to kind of create and manage the user. The question is that what if I already have a different corporate directory? Then you can use something called as Google Cloud Directory Sync, also known as GCDS. Your administrators then can enable the capability to leverage the GCP resources, and you can have the same username and password that your company has been using for years on those popular Active Directory service platforms like the Microsoft Active Directory or the LDAP. So we have understood about the Google Cloud Platform terminology, Google Cloud Platform Resource Hierarchy, IAM. And if you have any question, please put on the chat and someone will really answer that. All right. Do not hesitate asking a question. Now I'm going to introduce you different ways how you can interact with the Google Cloud Platform. All right. It's very important to see how the platform works, but then how do you interact with that? Four ways that you can interact with a Google Cloud platform. Now, console is basically the Google Cloud GUI, which is the graphical user interface, which basically allows you to do all the kind of deployment, scaling, any activities in a simple web-based interface. Then we have a SDK. Now, Google Cloud SDK is you can say a set of tools which allows you to manage the resources and applications which are hosted on the Google Cloud platform. And then you have something you with GSDK, you get something called as a G Cloud tool, which is basically a command line interface of, or you can say the Google Cloud CLI interface to interact with the product and services. Think about like GS Util or a BQ, for example. There's some tools for that. So when you install the SDK, you get all of these tools within the SDK, which are going to be located under your the bin directory. There's something called as Google Cloud Shell. If you see, the Cloud Shell provides you with obviously the command line access. That's why it's called a Cloud Shell to your cloud resources directly from your browser. Now, what is Cloud Shell? It's basically a Debian-based small VM with a persistent 5 GB of space, which makes it pretty easy to manage your projects and resources. When you use a Cloud Shell, the cloud SDK command that you would run locally will actually the one that you run on the Cloud Shell. The Gcloud command and all the utilities that you would need will be pre-installed on the Cloud Shell. And then you have the APIs and obviously the services that make up the GCP offer the APIs now, which basically allows you to, you can say, programmatically control your environment with the help of code. So if you have a piece of code and you want to access a resource, how we do that with the APIs. So cloud APIs, they provide you the functionalities which are pretty similar to the Cloud SDK and Cloud Soul, and they kind of, I would say, they're more relevant when you're trying to automate your workflows by writing code. You can use any favorite language, and you can use these cloud APIs with the REST calls and the client libraries in most popular programming languages. And then we have a Cloud Console mobile app. What it does is that it gives you a very easy way to understand and respond if there are any production issues. I mean, you can monitor and make changes to the Google Cloud Platform resources, even from your iOS or Android devices. So the Cloud Console mobile app is a very, I would say, a convenient way to understand the resources, and it's a great way of kind of accessing your resources on the go. So what's last for us is billing, labels, and quotas. Now we've understood the platform, we've understood how do we access that. Let's understand why billings and labels and quotas are really, really important. And now I'm going to present you how um, the way billing works in Google Cloud Platform. How do you control the spend of your? I mean, you don't want to just get a crazy bill, right? I mean, you don't want to run a service on, then you see over the weekend you have a crazy bill of maybe tens of thousands of dollars. So you want to control all those things. Now we know that the IAM policies, they are kind of inherited top to bottom. That means the billing is kind of accumulated from the bottom up. And if you can see on the right side, resource consumptions is measured in quantities, right? Like the rate of use or time on number of items or the feature. Now, because if you know the resource is going to belong to one project, so the project is going to accumulate all the consumptions of its resources, and every project is going to be associated with the one billing account, which means that an organizational node can contain all the billing accounts. If we talk about organizations, we know that each GCP service has its own pricing models, and there's something called as a GCP pricing calculator. I will recommend to use that in order to estimate the costs of the collection of resources. It's a great tool, you can use that. And the pricing calculator is basically a web-based tool that allows you to specify the expected consumption of certain services and resources. So what you'll do, you'll receive an estimated cost for the utilization of these resources as the output from the calculator. For example, let's say you can specify that you want to use N1 standard 1 VM instance, maybe in US Central 1, uh, you know, uh, zone with maybe 100 gig of egress traffic to maybe America or EMEA. So what happened? The splicing calculator is going to return you the total estimated cost, and then you can adjust the currency and the time frame also, which is going to meet your needs. And when you're done, then you can have it email you or get a specific URL for the reference. Remember that the resource, the consumption happens from the bottom up. So you have a resource which is going to have a specific billing type based on what exactly it is. Could be the use or number of items or what a feature, and then those get built to a project which are controlled by one or can be controlled by one organizational account. What is a resource quota? You will say, okay, hey Vishal, we're in a cloud. Why there's a quota? We can use literally anything, right? Yes, that's correct. See, cloud resources, they have near unlimited capacity, and you pay for what you want to consume. So these quotas really are for you. That means they protect you from any unintentional expenditure, and that's the reason all the resources in the GCP are subject, you can say, project quotas or limits, where the purpose is to basically encourage you to make those capacity planning more of like a priority, and then you set up the upper limits for the resources. And it's a very great thing. I mean, think about like decreasing a quota on the amount of CPU. So the default quota CPU is 24. That you can have a 24 CPUs max in a project. So you can decrease a quota to six if you are doing some kind of a testing in the project. So you will know that in any point of time your project will not increase six CPU. Or think about this way: let's say you're trying to launch 10 VMs and accidentally you press one more zero. What's going to happen? It will trigger 100 VMs. But since there's a quota, it's going to stop and it will prevent that. So if your project exceeds a particular quota while using a service, then you're going to get an error. So given these quotas, you may be wondering then how I'm going to spend, let's say, maybe a 96 core VM. Now, as I said, you as your use of GCP will expand over time, your quota will increase accordingly. But let's say if you are expecting some kind of upcoming increased usage, you can proactively go ahead to the GCP and request that quota adjustment from the quota page and the console, and then it will. Someone from the GCP team will actually increase the quota based on your request. Sometimes project quotas prevent the runaway consumption if this in case of an error or some kind of attack. So it's very important for you to always understand the quotas and remember now you get an answer that okay, Google does give you unlimited or near to unlimited capacity, but for your safety they also provide quotas so you don't accidentally get a crazy bill. All right. Now, let's say if I'm going to get a crazy bill, how do I really get insured about that? That's where budgeting comes into play. Now, to help with the project planning and the controlling costs, you can really set up a budget, and you can, once you do that, it allows you to track how much spend is growing towards that amount. And if you see a screenshot, it shows the budget creation interface. So you basically set a budget, name and specify which project this is going to belong to, and then you specify the amount, and then you determine the percentage alerts. Let's say if my amount is maybe $100, then I will create an alert maybe of 50%, 100%, and maybe 20%, and then you will use these alerts to send emails to maybe the billing admins, or after the spend has exceeded, or maybe after 50% you send it to billing admins, after maybe 100% you send it to not just the billing admin, you send it to the CTO, and after more than that you send it to CEO also. So alerts are one of the most important thing that you want to use, because normally a project admin is never bothered about the budget, but the one who's bothered is going to be a CTO or the managers or the CEO. So if a budget is going to increase, let's say by 100%, then the one person who will be considered, I would say worried, would be the CEO or the CTO. So you send them the email, hey, the budget has increased 100%. Is this fine, or you want to do something? And then those people are the one who will take the necessary actions. But and that's the only way they will get to know what's happening, right? So it's important to set the budgets and alerts in order to not go beyond your spending capacity or limits. Now, once you have the budget alerts, important also, I would say, to know what resources are being used for what purpose, and that's where labeling comes into play. So you would create a label to define the environment of your VM. So for example, you define a label for if each of instance, let's say either this is a production instance or it's a test instance. And then you can use this label. You could search and list all of your production resources just by writing the prod as a tag. So labels can be used in the scripts if in order to help you to understand the cost, or if you're running some kind of bulk operation on multiple resources. And the screenshot, it shows you example of four label that are created on an instance. See, we recommend adding label based on team or cost center if you want to distinguish the instances which are owned by different teams. For example, you can label maybe the marketing team or the team research. If you see, the labels are basically key value pair. Okay, so you can put a key and value there. If you can use a team marketing or team research, you can use labels to have from the component side. You can have, let's say, front end component, back end component, and you can use label based on your environment. So you should always consider using labels to define, I would say, a owner or a primary contact. So it's important to do that, and you can able add labels to your resources to define a state. Also, for example, you have a state, maybe an in-use state, or you can have a state maybe ready for deletion. So labels can really help you to find and analyze resources and use them and leverage them to the best of the capacity. so that it is easy for you to manage the Google Cloud infrastructure, not the other way around. If you have these labels, you can even visualize your billings and everything. There's a great tool called Data Studio, so you can visualize all those spend over time with the Data Studio. What it does is basically turns your data into very informative dashboards, and then they're pretty easy to read and understand, and they're absolutely customizable. So you can slice and dice your billing reports. I mean, if you're a data analyst, you're pretty much, I'm sure you've, if not exposed, then you must have heard about it as Studio. It's a great tool to kind of leverage that. We come to the next segment for the day. So we have understood in this module about the GCP fundamentals. We spoke about the infrastructure service and different other options. We understood about the various components of Google Cloud. We understood about um, how do we access the console, and we understood about the quotas and IAMs and the billings, and it was very important stuff to do that. All right, so now we're in the module where we will be talking about virtual machines and network in the cloud. This is one of the most interesting thing that you would be doing on the Google Cloud. And as I said before, if you have any questions throughout the today's event, please feel free to enter the text in below and someone will answer you. We have the Google experts who are on the standby to answer your questions live. And please do not forget to participate in all the quizzes that we're doing. It's really important for you to really see what you're learning. All right, so let's understand now. In this section, we will learn about how do we create a virtual private cloud, how your networks are actually hosted on Google Cloud infrastructure, right? You will be running a virtual machine and you will be having a network. You must really know how that network is set up. You're going to learn how you control the access to your network with some kind of firewall rules. You will learn how to create subnets, and in networking, we know what subnets are. You will learn how to create and manage a virtual machine in a compute engine, what kind of configuration is right for us or not, how does compute engine pricing really work, and finally we'll try and understand how would we create a connection between maybe your on-prem environment or source environment and your virtual private cloud. So let's see. These are things that we'll learn, and in this segment we will learn about the physical geographic location distribution of the Google Cloud. That's one of the most important things actually. So what we are seeing here is a region and a zone. Now, what are regions? Regions are independent geographic areas which consist of zones. So you can say a region is sometimes referred by a continent or some kind of a number. For example, you have this Europe West 2, which is a region in London. And a zone is basically a single physical data center, and most regions have either three or more zone if in order to kind of have redundancy. Now, the slide that you see right now, and what we're having three zones that you are seeing here, with your West 2A, 2B, 2C, and then you can put a resource in any of the three zone, which is a part of a region called as Europe West 2. So what happens, you can put a resource maybe in a zone A or zone B, and then you can actually have them isolated. So that will one of the ways to kind of put your resources into different zones in a region. So now that we have these regions, obviously Google has regions across the world. How are they connected? And it's very important to understand. Now we know that Google Cloud Platform, it kind of has services which are globally distributed across North America, South America, Europe, Asia, Australia, and all these locations. Now you know that they would be divided into regions and zone. Because of such a great network continent, Google has been able to give you a very minimal latency infrastructure. The network infrastructure is composed of a lot of edge points of presence, which is, or you can say, which are the Google's network connects to the rest of the internet. So GCP can actually bring its traffic closer to its user because it kind of operates at an extensive global network of all those interconnection points. If you see in the slide, we have all these dots which are basically connecting the Google network infrastructure, and this obviously reduces the cost and provides a user with an absolute better illustration. And all these lines that you see here, they are representing the private, and that's in submarine fiber optic cable, which is spread across the globe to connect all the GCP resources. You can imagine how great and how big and how huge is the Google's global network. The next thing we want to learn about is how do we leverage the Google's physical infrastructure when we want to create and configure our own virtual private cloud network, because you've seen that network is huge, but when you are running your resources, you want to have a separate isolated network which is not completely in sync with anything else. You want to have it completely isolated and secure. How do we do that? And that's where the concept of the VPCs comes into play. Now, initially, when you launch a project, and let's say you want to launch a resource, how will you do that? So, by default, when you launch a project, it's going to come up with a default virtual private cloud, which is called as VPC. I'm going to call it a VPC now, which is your global network. So, if you're looking a way to segregate your resources, then you can have more than one VPC in your project. And your default VPC is basically a global network, which is span across all the available regions across the world that I showed you in the previous slide. Now, this basically provides you what? It provides you a simple one cloud interconnected network, which is literally existing anywhere in the world. And all the resources inside a VPC can communicate over the RFC 1918 private IP ranges, which is about for 10.0 and then the 198.0. So you can have these IP addresses within your VPC subnet, so you can have resources that can talk internally. And then inside a network, you can also segregate your resources with the regional subnetworks. Then you can have an IP address associated with range with them, and all those subnets then they can span across the zones which makes up a region. That means you can have resources in different zones on the same subnet, which kind of makes, you can say, management and fault tolerance pretty easy. Think about, like, let's say there's a VPC, okay, and it has a subnet maybe in a US East 1 region. Then what happened? Then the IP range is going to span across all the zones in the region. So both your virtual machines um, will be a part of same subnet, even if they're running in a different zones, because that network belongs to a region. Couple of things to understand that VPC networks, they have their own routes and firewall rules, and all the subnets, as I said, are kind of regional resources where they defines a range of IP addresses. I mean, the traffic which is going to come or go from the instance, then it can be controlled with firewall rules. I'll talk about that. Resources within a VPC. So if you have a VPC and you have resources within VPC, they all can communicate with another using those private IPv4 address that we define. Obviously, then you have to define the firewall rules for that process. So this is something how the network is kind of structured. And when you talk about VPC, you just know that we spoke about the default network, which is one of the three VPC network options that GCP provides you. And you see on the screen, we know about default. Now, at Google, we recommend using the default VPC when you're new to this and you're prototyping and you're doing some kind of test instead of a production workload. So it's always great practice to use a default network, so you don't have to really juggle around with the VPC. But then we come to an auto mode. Now, what happens to auto mode network? We get one subnet from each region, which gets automatically created. So default network, you can now say, is actually an auto mode network that you can manually add and have greater freedom to kind of modify it. And these subnets are, they use a set of predefined range with a mask of /20 to expand to /16. And you know what a subnet mask is. If you have /20, we have, you can say, about 4,000 IP addresses. If you have 16, we're talking about 65,000. So all of these subnets which fit in the range of 10.188 sided block. So as new region in the GCP kind of becomes available, all these new subnets in those regions will be added to that mode. And finally, this is a custom mode, which is more on when you're building a production network. It's basically a network which automatically is not going to create subnets. So this type of network provides you with complete control over its subnets and IP address range. You decide which subnets you create. You decide on regions you want to choose, and using the IP address ranges you specify. And these ranges, one thing to always remember, they cannot overlap between the subnets of the same network. Always remember one thing before we move to the next slide is each VPC network will consist of one or more IP address partition, which we call as subnets. And each subnet is going to be associated with a region. So VPC networks, they do not have any IP address range associated with them. IP address range are defined for the subnet. So always remember, don't confuse that, hey, my VPC doesn't have a network. No, it's going to be a subnet inside the VPC. That is where you define the IP address range by which your network or your resource will be connected. So your network will need to have at least one subnet before you can kind of use it. Okay. So once we have the VPC network, obviously we have the firewall rules. Obviously, VPCs gives you a globally distributed firewall, which you can really leverage to control the access to your instances. And all these VPC firewall rules, they apply to a given project and network. So let's say if you want to apply firewall rules across an organization, there's an option to do that. When you create a VPC firewall rule, then you would specify a VPC network and you would specify the set of components that define what the rule does, and that kind of enables you to target certain types of traffic based on some protocol or port. Let's say I want to only allow port 22, maybe from a specific IP address, or maybe I want to allow, let's say, port 80 to a web server. So you can define all those things in the firewall rules. So all the GCP firewall rules are stateful. That means the firewall rules allow a bi-directional communication once you have established session. And one more thing before we kind of move to the next one is that's important that you mention all the networks that comes with some kind of implicit rules. That means if there is no firewall, I mean, in the absence of a firewall rule in a network, there is still an implied deny all ingress rule. That means by default, you will have every traffic in a denied all mode, ingress one, and every egress traffic as an allow all. All right, moving further. Now we'll learn about compute engine and virtual machine. This is really, really important because until now, you have been talking about, or we have been talking about regions and networking, and let's see how the virtual machine compute engine are working. Now, GCP provides IaaS. That means the GCP is going to manage the physical servers and the services for you, and they provide you a familiar virtual machine environment without even need to maintain them. So Compute Engine basically provides you with a lot of configuration options, and you only pay for what you provision with no upfront cost. So you essentially choose how much memory, how much CPU you want, and you choose the type of storage you want. Maybe you can choose a hard drive, a standard hard drive, which is a magnetic tapes, or the SSDs, or maybe a mix of that. And you can configure the networking interface and then choose the operating system to run your virtual machines. And that's something which your company can offer in a normal way, that you would have the memory, you will have the CPU, you will have the storage and the network, and there you will have your entire compute instance running for you. Now, in GCP, each virtual machine can have two IP addresses assigned. One of them is going to be an internal IP address from the subnet under which you have created that resource, which is assigned via the internal DHCP. So when you create a VM in a GCP, it's gonna have it name registered in a symbolic way with an internal DNS service, which is then going to translate the name into an internal IP address. And the DNS is going to be scoped to a network. And the other IP address is going to be the external IP address, which is optional. The external IP address then can be assigned from a pool, which makes it ephemeral, or it can be assigned as a reserve external IP address, making it pretty static. And remember that you will be billed for reserving an external IP address when they're not attached to a running VM. So let's say you have asked for a specific static IP and then you're not using it, then GCP will bill you for that. All right. And that's how you understand that why there's a need for an internal IP address and why there's a need for an external IP address. Now, once we have understood the concept of compute engine, we should really understand that what kind of machine I should use. I mean, we have got different type of machine types than we when we talk about the GCPs. Now, what is a machine type? A machine type is basically your virtualized hardware resource, which are going to be available when you're going to create a virtual machine instance, which will include what? Which include the system memory, vCPU, or some kind of persistent disk. So in compute engine, machine types are then groups and curated by families for different workloads. If you see here, F1, G1, N1, they're nothing but family types, and you can choose from general purpose, memory optimized, and compute optimized families. And you know, each machine type family is going to include different machine types, and they're going to be designed for a specific workload. If you see here, we have a high memory, we have a high CPU, we have standard, we have shared core. So you can imagine they all are meant for different purpose. So a shared core machine type is going to provide you one vCPU only with the zero point 0.6 gig of RAM, where all these instances are really meant for a cost-effective purpose when you have a really, you can say, a very non-resource intensive application. Now, apart from that, we have a standard machine types which are suitable for tasks that needs a balance between the CPU and memory. So if you see, we have a machine type which has a 3.75 gig of memory per vCPU. So let's say if I have two vCPU, we're talking about 7.5 gig of RAM. If I have four vCPU, we're talking about 15 gig of RAM. That's how you can differentiate. And each of these machine supports up to 64 terabytes of persistent disk size, which is pretty much the case for the rest of the machine types also. So a compute optimized machine type, I would say they offer you the best and the highest performance per core on the compute engine. They're built on the latest generation Intel scalable processor, which is a Cascade Lake series machine types. They offer you up to 3.8 gigahertz of sustained all core turbo, and they kind of provide you full transparency into the architecture of the underlying server platform. So if you're looking for a high compute optimized application, go for the high CPU machine type, which is great in that case. So these are different standard families, and there are more options. So when you start building a VM, you will kind of get there. But what if I want a custom machine type? What if I don't want to use these one? Obviously, we have an option. If none of these predefined machine types matches your need, then GCP provides you a unique feature called as custom machine types, where you can independently specify the number of vCPU and the amount of memory, for instance, you need. And if you're having a workload that are not good for any of these predefined machine types, you can use a custom machine types by just dragging and dropping, from left to right, right to left. You can just choose your amount of vCPU and memory you need, and that's how easy that process it. But into a custom, you can say compute engine, you can do this part, and that's where the kind of billing comes into play. So GCP is going to charge your VM per second after the first minute. So the moment you run a VM instance on the Google Cloud platform, after the first minute, everything that will be charged based on the per second. That means you only pay for the time your machine was actually running. And there are some kind of discounts, which are, you can say, automatic discounts that you get for running a specific compute engine resource for a significant portion of a billing month. For example, let's say if you are running one of those discount resource for more than 25% of the month, then compute engine automatically gives you some kind of discount for every incremental minute you would use for that instance. Now, all these discounts are known as committed use discounts. If your workload is stable and predictable, you can use a specific amount of vCPU in memory for up to 57% discount of normal prices in return for committing either for a year or three. I don't know why I don't have 2 years, but that's how it is. Now, there's also something called as a preemptible virtual machine. Now, what is a preemptible virtual machine is something we should remember. A preemptible virtual machine is an instance that you can create, run at a very lower price than a normal instance. The only thing with the preemptible is that it can operate up to 24 hours only. Okay. So these are the availability of a preemptible virtual machine depends upon the free resources at the compute side. So if you have increase in demand for excess resources, then all these preemptible virtual machines can be terminated within up to 30 seconds. And they're great for, I would say, non-operational work. Think about like a batch processing application where every day at 4 o'clock or maybe 5 o'clock you need maybe 20 vCPU more than what you would use in the entire day. Use a preemptible virtual machine where you don't have to pay for the traditional on-demand pricing. And that's how these pricing kind of works on the GCP. Now look in this way. You have the sole tenant nodes where you can keep your instances physically separated from instances in other projects, or to kind of group your instance together on the same host hardware. So you always have those all those options. You're not ruled out of just sticking to what's provided. You can always customize it to the way you need in all the case in GCP. So what next for us? So we've understood about the compute, which is memory and the CPU. Obviously, we would still need storage within that, right? So let's talk about the storage. Now, what are persistent disks? Persistent disks are, you can say, iSCSI disks. You can kind of compare them like an iSCSI disk on the prem. So these are the network attached block storage. If I remember, I'm using the block storage, and your data is, in this case, is persistent. That means your data is going to be durable. It's going to outlive the machine life cycle. So these persistent disks, they offer us redundancy because the data on each persistent disk is distributed across several physical disks. And we really recommend you to choose a persistent HDD disk when you need just a storage solution. You're not really worried about the performance. Then always recommended to use those traditional magnet tapes HDD disk. But let's say if you have a high performance requirement, then it's always recommended to use the SSD option. And if you're looking for a non-persistent storage, then local SSDs are the best, where you are getting the maximum throughput and the lowest latencies. Because why? They're physically attached to your virtual machines. And that's what something the persistent disk is about us. So each compute engine virtual machine, it comes with a virtual network interface controller. We call it VNIC. Now, every network interface has a throughput which can scale at 2 gig per second per vCPU. Remember, 2 gig per second per vCPU, up to 30 gig per second with 16 vCPU cores. Now, because we know that persistent disks, they're accessed over the network instead of physically attached to a VM, they also use the allocated network bandwidth the machine has. And you can have up to 8 NICs, which can be attached to different VPC network. I mean, for example, let's say you want to have a network appliance that has one NIC in maybe your DMZ VPC and maybe one in your internal VPC. You can have up to 8 NICs that can be attached to different VPC network, and that's how networking operates. Okay, great. Finally, we come to talk about internetworking networks. It's like, okay, we have multiple VPC. What do we do? Let's say if I have resources in different zones, or sorry, different regions, and there are different VPCs, how do we really connect them? Is there a way to connect them, right? Because VPCs are technically isolated environments. How do we really connect them? So now it's important for us to ensure how do we connect to a Google Cloud platform. Most of the customers that we've observed, they start with a VPN connection, a virtual private network connection over the internet, which leverages the IPsec protocol. Now, VPN connection is pretty easy to set up. It doesn't require any kind of physical connection between your on-prem and the Google Cloud Platform data center. So there's a service called as Cloud VPN, which kind of connects your on-prem network to your GCP VPC through a IPsec VPN tunnel. Now, the traffic which is traveling between the two network is always encrypted by VPN gateway, and then it's decrypted by the other VPN gateway, which kind of protects your data if it's kind of travel over the public internet. That's why Cloud VPN is useful when you have, let's say, low volume of data connection. It's a managed service with SLA of up to 99.9% of service availability. But let's say in the VPN, you still want to use the internet. But let's say you don't want to use internet, right? Because of some kind of security concern, or let's say you need more reliable bandwidth or some kind of lower latency. There's something we call as Google Cloud Interconnect. It's kind of a private connection to your VPC. So if your on-premise topology kind of allows it, you can use some kind of dedicated interconnect, which connects your on-prem to one of the GCPs or Google's data centers directly. So a dedicated internet literally provides you a direct physical connection between your on-prem network and the Google's network. which enables you to transfer large amounts of data between network, which can be more cost effective than purchasing an additional bandwidth, which is going to be very costly. And if you want to use a dedicated internet, then what is required is that you would be required to provision a cross connect between the Google network and your own router in a, you can say, a common co-location facility. I'll talk about that. And then we have this something called as partner interconnect, which provides you a connectivity between your on-prem network and your VPC through a supported service provider. So you can say a partner connect will be useful if your data center is in a physical location that you cannot reach via a dedicated internet co-location facility, or let's say if you need speed more than 10 Gbps. So if your data needs entire 10 Gbps of connection, then it's always something you can leverage part interconnect. Now, if you want to use dedicated interconnect, your network must physically meet um, Google's network in a supported co-location facility. And if you see this map, it shows the location where you can create a dedicated connection. Now, you might look at this map and say, well, hey, I'm nowhere near one of those locations. And that's where what would you use then? That's right. We will use partner interconnect, because now if you're not anywhere near these locations, then you would use partner interconnect. So we have three things: VPN, dedicated interconnect, and partner interconnect. Let's try and understand a comparison between these. So the VPN tunnels that Cloud VPN offers, they have a capacity of 1.5 to 3 gigabytes per tunnel, and then they require a VPN device on your on-prem network, and you can configure multiple channels if you want to kind of scale this capacity. The dedicated internet has a capacity of 10 gig per link and requires you to have a connection in a Google supported co-location facility, as we showed in the previous slides. You can have up to 8 links to achieve multiple of 10 gig, but 10 gig is like the capacity that you can have in the case of dedicated interlink. And finally, the partner interconnect, which has a capacity of 15 MB to 10 gig per connection. And as you know, requirement is more about when you are not in a nearest co-location facility of Google, so you can't use the dedicated internet interconnect. Now, one of the recommendations is always to start with the VPN tunnels, and then if you need some kind of enterprise grade connection to DCP, you can switch to dedicated interconnect or the partner interconnect, depending upon the proximity to a co-location facility and your capacity. So in this section, we have learned how do we create a VPC. We spoke about network hosted on DCP infrastructure. We understood about how to control the access of network with the firewall, how to create subnets. We learned about how to manage the virtual machines and compute engine, choose the right configuration, understand the compute engine pricing, and finally we understood about how do we create a network connection between the source environment and your VPC by the different options like the VPN and dedicated internet connect and the partner interconnect. And that brings us to the end of this section. So let's get ready for the next.